Hello, I'm Steve Reyes, Product Manager from Anritsu. What we're showing today is the VectorStar Broadband system that operates from 70 kilohertz to 145 gigahertz. Normally, a broadband system is operating up to 110 gigahertz so that we can do device modeling and provide the information of the device from near DC all the way up to the highest frequencies possible. The wider the bandwidth that we provide of the device, the more accurate the models will be, and therefore more success during your design stage of mimics and other types of power amplifiers and other active devices. If you're able to go beyond 110 gigahertz, for instance, in cases where you're measuring and designing WR10 waveguide or 94 gigahertz, not 77 gigahertz types of applications, you would like to go even beyond 110 gigahertz. Up to now, we haven't been able to do that because that's the next waveguide band. It goes beyond the geometry of the 1 millimeter connector that we normally use. And so there's a number of interesting challenges that we have to overcome in order to combine that next waveguide band into the 110 system. So that's what we've done by modifying and enhancing the performance of our nonlinear transmission line modules, which use the shock line technology that derive and provide the information needed all the way up into the millimeter wave bands. So what we do is we combine the capabilities of VectorStar, starting from 70 kilohertz, and in this case we're using a 70 gigahertz model, and we're sweeping the microwave frequencies using VectorStar through those frequencies. So with the module, we're actually transmitting from VectorStar and transferring the information along a transmission line from 70 kilohertz to, in this case, 54 gigahertz. And then starting at 54 gigahertz, we multiply the signals up in various bands. So for our standard 110 gigahertz modules, we are going from 54 gigahertz to 80 gigahertz, 80 to 110 or 125 even, in this case for the original nonlinear transmission line modules. Then in order to get to the next band, we add another multiplier band, and we're multiplying from 110 to 145. And that's what these new modules are doing. Now, in order to be able to provide the information needed through a coax connector, we need to provide a smaller geometry connector than the 1 millimeter. And that's why we've developed and designed a 0.8 millimeter connector. The 0.8 millimeter connector can go all the way up to 150 gigahertz. So in this case, we're using that connector as our test port and going up to 145 gigahertz. So all of the benefits of the modules that we have been providing over the last couple of years up to 110 are part of the 145 system. So that includes things like true directivity for maximum stability and also widest dynamic range possible, because we can actually do a direct connect to the probes for on-wafer measurements. So on-wafer measurements is a majority of types of applications used for broadband systems, and therefore being able to mount the modules on a probe station is quite important. So that's why when we developed the 145 gigahertz modules and total system, we also were working with probe station people and probe vendors in order to provide the probes at the same time as we were showing the modules and providing the modules. So, so that's what we have here, is we have a direct connect to a GGB probe going to 145 gigahertz using their standard substrate and characterizing the system up to 145 with better than coax accuracy. And we're also mounted on a probe station. This one's from Signatone. And you can see that the small compact size makes it quite easy to mount the system in any configuration, whether it's east-west or north-south. And also, when you're looking at the modules for going into differential types of measurements, you can see that it's quite easy to mount two modules on the positioners and make it such that the connections from the probe to the modules are quite short. So that also maximizes your dynamic range. And it also makes it quite easy to mount a differential system on a smaller station so that you don't need to go to the expense of quite large platens in order to make those measurements. So that's the total concept, starting off with VectorStar and going up to the 54 gigahertz, transferring over to our modules, and then multiplying the signals up and providing the information that's needed for device characterization engineers who are looking for broadband measurements over widest range possible. Okay, thank you very much for your attention.